Hello, dear students. Welcome back to the fourth lecture of the lecture series on machine design. In the previous lecture, I have explained you the design of butt joint and then solved some related problems. I hope by now you must have already gone through that lecture, and since I didn't see any questions in the comment box or on my WhatsApp group, I assume you have already understood it very well. In this fourth lecture, I'll explain you the design of parallel fillet joint and transverse fillet joint, and then try to solve some related problems. So let's start with the design of parallel fillet joint, and before that I'll just explain you once again what a parallel fillet joint is. A parallel fillet joint is a joint where the applied force or the applied load on the structure is parallel to the length of the weld. So this figure over here, this figure A over here shows you a parallel fillet weld subjected to tensile force P. This is your plate number 1, which is perpendicular to the plate number 2 and is overlapping some part of the plate number 2, and this is your weld. This is your weld which is subjected to a tensile force P like this. Now the length of the weld given to you is L. L is the length of the weld, and this is the cross section of your weld, which is in the form of an isosceles right angle triangle, and an enlarged view of this isosceles right angle triangle or the cross section of the weld is shown in the figure B. Now in this figure you can see that this length is equal to this length, since this is an isosceles triangle, and we call this length as the leg of the weld, and it is denoted by the letter H or the alphabet H. This length over here is known as the leg of the weld, and it is denoted by alphabet H. And as a rule, we take the length of the weld, the leg of the weld, which is denoted by alphabet H, as the thickness of the plate. So always keep in mind that the leg of the weld is taken equal to the thickness of the plate. Now you can see that this is a parallel fillet weld, and any weld or any structure fails from the minimum cross sectional area. It is more prone to failure at the minimum cross section area. Now this figure B shows you a plane passing at an angle of 45 degree with the leg of the weld. Now this is the minimum length, and when multiplied by the length of the weld will give you the minimum cross sectional area of the weld, and this minimum length is denoted by alphabet T. This is denoted by alphabet T. Now this T is at an angle of 45 degree with the leg of the weld. This is at an angle of 45 degree with the leg of the weld. Now this length is known as the throat of the weld. So always be careful while solving the problem whether the leg of the weld is asked to you in the question or the throat of the weld is asked to you in the question. Now if you apply simple geometry, you can easily find out the value of throat in terms of leg of the weld. Now your throat or T is equal to cos 45 times the leg of the weld, which is equal to 0.707 times your leg of the weld. Now I hope this is clear to you why we are taking the cross sectional area across the throat of the weld. This is because this will give you the minimum cross-sectional area, and any structure is prone to failure or will start the failure from the minimum cross-sectional area, because the strength at the minimum cross-sectional area is obviously low as compared to the other cross-sectional as compared to other points. Now this parallel fillet weld is prone to failure because of the shear load. It will fail due to the shear across the minimum cross-sectional area, which is through the throat of the weld, and which is equal to T times the length of the weld, where T is the throat of the weld. Now, as I told you, if you apply simple geometry, you will easily find out the value of T in terms of H, which is the leg of the weld, which is shown in this figure, that your T or the throat of the weld is equal to cos 45 times the leg of the weld. So your throat of the weld is equal to cos 45 times leg of the weld, which is equal to 0.707 times H. Now, as you can see in this figure, there is only one parallel fillet weld, whereas in general practice there are two parallel fillet welds. So this equation is valid for single parallel fillet weld. Okay, or rather this equation is valid for single parallel fillet weld. Now what this equation is giving us? This equation is giving us the shear stress induced in the parallel fillet weld across the minimum cross section area, and we are considering minimum cross section area because that is the point where your failure will start. Now your shear stress is equal to the applied load, which is the tensile load, and the magnitude of that load is P, divided by the area or the minimum cross sectional area of the weld, which is T times L, or points, if you substitute the value of T, it is equal to 0.707 times H times L, which is the length of the weld. So from this equation you can calculate the strength of weld if you put the shear stress equal to the allowable maximum shear stress. So in case you put, this is your maximum allowable shear stress, this is the length of the weld, and this 0.707 times H is the throat of the weld, and this will give you the strength of the plate or the strength of the parallel fillet weld. Okay, this will give you the strength of the parallel fillet weld. Now this equation is valid for a single parallel fillet weld. In case you have two parallel fillet weld, you have to multiply this with 2 as shown in this figure. In case of double parallel fillet weld, you have to multiply the complete equation with by a factor of 2. So this will give you the strength of the plate equals to 1.414 times H times L times tau, where P is the tensile force on the plates in Newton, H is the leg of the weld in millimeter, L is the length of the weld again in millimeters, and tau is the permissible or the allowable shear stress for the weld in Newton per mm square. And this equation will give you the strength of the weld. Now, in some of the books, the required length of the weld, basically in some of the books, there is an addition of 15 mm in the required length of the weld. This is because to allow for starting and stopping of the weld run. But in your examination, you need not to add this 15 mm in your length of the weld. You can calculate the exact value of the length, and that will be your answer. You need not to add this 15 mm in the length of the weld. But as a practice, on some of the books, this 15 mm length is added to the final length of the weld in order to allow for starting and stopping of the weld run. And the point which I want to tell you is that in case of static loading, the permissible shear stress for the fillet weld is taken as 94 megapascal or 94 Newton per mm square as per the code of American Welding Society. So in case the permissible shear stress is not given to you in the examination, you have to always take it as 94 Newton per mm square or 94 megapascal as per the American Welding Society. So this is how you are going to calculate the strength of a double parallel fillet weld or a strength of a single parallel fillet weld. If you take this factor of 2, this will give you the strength of the double parallel fillet weld. In case you omit this factor, it will give you the strength of a single parallel fillet weld. Now let's talk about the strength of the transverse fillet weld. Now in this figure over here, in this figure A, you can see that the direction of the applied load is perpendicular to the direction of the weld. That's why we are calling this weld as transverse fillet weld. Now this transverse fillet weld subjected to a tensile force of magnitude P is shown in this figure. The minimum cross-sectional area again in this case will be across the throat. Now this is the cross-section of the transverse fillet weld. Now again this fillet weld will fail across the minimum cross-sectional area, which will be given by throat T times the length of the weld. The length of the weld is given to us as L, and T is at an angle of 45 degree as in the previous case. So your T in this case will also be equal to cos 45 times the leg of the weld, or H. Again the nomenclature will be same for this transverse fillet weld as it was in parallel fillet weld. T is your throat, H is your leg, and as a rule we always take H or the leg of the weld equal to the thickness of the plate. You can see here that H is leg, T is your throat. And the cross section of the weld is again your right angle isosceles triangle, where this length is equal to this length and taken as H. And again your weld or the transverse fillet weld will fail across the minimum cross sectional area given by the throat of the weld, which is equal to throat times the length of the weld. But in case of parallel fillet weld, the failure was because of the shear load across the minimum cross sectional area, whereas in case of transverse fillet weld, the failure is because of the tensile stress. This time it is because of the tensile stress, but again across the minimum cross sectional area, because that is the weakest point in the weld. Now the tensile stress in the transverse fillet weld is given by this equation, which says that sigma T, which is the tensile stress developed inside the weld, equal to the applied load, whose magnitude is P, divided by the minimum cross sectional area of the weld, which is given by T times L. If you substitute the value of T in this equation, you will get this equation, which says that your sigma T is equals to P divided by 0.707 times H times L, where 0.707 times H is the value of your throat. Now if you rearrange the terms and put the value of sigma T as the allowable or the maximum tensile stress, you will get the strength of the plate. You will get the strength of the plate, which is equal to 0.707 times H times L times sigma T, where sigma T is the permissible tensile stress for the weld given in Newton per mm square or megapascal, and your H is the leg of the weld, again taken in millimeters, and length of the L is the length of the weld taken in millimeters. Now, please keep in mind to take to take all the units as per the given given in this lecture, or try to be consistent with the unit. Otherwise, in spite of putting the correct values, you will get the wrong answer. So always try to be consistent with the units. Now this equation gives you the strength of the weld for single transverse fillet weld. Now as I told you in the previous lecture that we rarely use a single transverse fillet weld, because if we are going to use a single transverse fillet weld, the edge which is not welded will warp out, because of which the total strength of the structure will be very less. So that's why for that reason we always use double parallel fillet weld. Now for a double parallel fillet weld, you have to multiply this equation by a factor of 2. Okay, you have to multiply the equation by a factor of 2 in order to get the total strength or the final strength of the plate for a double parallel for a double transverse fillet weld. So the strength of the double transverse fillet weld is given by this equation, which is equal to 1.414 times H times L times sigma T, where sigma T is the permissible tensile stress, and the strength of the double parallel fillet weld is given by 1.414 times H times L times tau, where tau is the permissible shear stress of the weld material. So we have seen that the transverse fillet weld fails in case of or because of the tensile stress. However, the actual nature of the stresses in the cross section of the transverse fillet weld is quite complex. The weld is also subjected to a shear stress in addition to the normal stress. In addition, the throat is subjected to a bending moment also because of the shear stresses, which adds to the complication. In the coming lecture, we can prove that the transverse fillet weld, in the transverse fillet weld, the inclination of the plane where the maximum shear stress is induced is inclined at an angle of 67.5 degrees with the leg of the weld. However, for the calculation or for the ease of calculation, we take only the tensile stress in account for the failure criteria of the transverse fillet weld, and it proves to work fine in case of transverse fillet weld. But as I told you, in actual practice there are tensile as well as shear stresses acting in case of double parallel fillet weld. But for the calculation purpose, you have to only consider the tensile stress. So your parallel fillet weld is failing because of the shear stresses, and your transverse fillet weld are failing because of the tensile stresses. Now, after deriving the equations for the strength of the plates or the weld for parallel fillet weld and transverse fillet weld, let's try to do some problem. From this figure here, you can see that the applied load is parallel to the direction of the weld. It is parallel to the direction of the weld. That's why we can treat this problem as the problem of parallel fillet weld, and this weld will fail because of the shear stress. So we will be using the equation to find out the strength of the plate, or the strength of the weld, as P equal to 1.414 times H times L times tau. We are using 1.414 times H because there are two parallel fillet weld. This is your first parallel fillet weld, and this is your second parallel fillet weld. And obviously, I told you in the previous in the previous slides also that your weld is going to break from the minimum cross sectional area, which will be from your throat. Now this question says that a steel plate 100 mm wide and 10 mm thick. So this plate is 100 mm wide and 10 mm thick. So your the 10 mm is the thickness of the plate, which will be taken equal to the leg of the weld, because as a rule we always take the leg of the weld equal to the thickness of the plate. So it is welded to another plate by means of double parallel fillet weld. It is already given to you in the question that this is a double parallel fillet weld as shown in figure below. The plates are subjected to a static tensile force of 50 Newton. It is subjected to a static tensile load of 50 kilonewtons. Now we have to determine the length of the weld in this problem if the permissible shear stress is given to be as 94 megapascal or 94 Newton per mm square. So the values given to you in the question are the thickness of the plate, that is 10 mm, the tensile force acting on the plates, which is 50 kilonewton, and the permissible shear stress, which is 94 megapascal. Now you already know that we have to use this equation. We have to use this equation which says that P, which is the strength of the plate, is equal to 2 times 0.707 times H times L times tau. Now we have to find out the question wants us to find out the length of the weld, which is L. So we have to find out this parameter. Now let's see what are if the other parameters are given to us in the question or not. Now the length of the plate is given to us as 100 mm, but this information is not required for us to solve this problem. So the tau, which is the permissible shear stress, is given to you in the question. P, which is the tensile force acting on the plates, is given to you in the question as 50 kilonewtons. And we have multiplied this equation by a factor of 2 because double parallel fillet welds are given, because this structure is welded with the help of double parallel fillet weld. This is your first parallel fillet weld, and this is your second parallel fillet weld. And obviously 0.707 is a constant, and H, which as a rule we always take equal to the thickness of the plate, is also given to you in the question. So all the values are given to you in the questions. If you rearrange the term, you will be able to find out the length of the weld. Which question wants us to find out. So if you put all the values properly with keeping the consistency of the units in mind, you will get the answer as 37.62 mm. Try to solve this problem at your end, and in case you have any problem, you know how to contact me and you know how to ask the questions from me. So these questions are not only important from the examination point of view, but those of you who are preparing for GATE examination, they also find it helpful in the preparation of their GATE examination, because similar types of questions are asked to you in the GATE examination. So if you have understood it properly over here, you will be able to solve these problems in your GATE very easily. Now this is another question where you can see that the direction of the applied load P is perpendicular to the direction of the weld. It is perpendicular to the direction of the weld. That's why this question can be treated as the question of transverse fillet weld, which is also given to you in the question. This is a problem of double transverse fillet weld. So this question says that two steel plates 120 mm wide and 12.5 mm thick are joined together by means of double transverse fillet weld as shown in figure, the maximum tensile stress for the plates and the welding material should not exceed 110 megapascal. Find the required length of the weld if the strength of the weld is equal to the strength of the plate. So this last line is very important, which says that the strength of the weld should be equal to the strength of the plate, and we will see in a moment that why this line is very important. First of all, let's see what are the information given to us in the question. The first thing given to us in the question is the length of the the length of the plate, which is 120 mm. Next information given to us is the thickness of the plate, which is 12.5 mm, and which will also be equal to the leg of the weld. Next information given to us is the allowable tensile stress which the welding material can withstand, which is equal to 110 megapascal. Now coming to this line, which says that if the strength of the weld, in this question the strength of the weld should be equal to the strength of the plate. So till now we are denoting the strength of the weld as P. Okay, we are always denoting the strength of the weld as P, whose value is not given to us in the question, but this information is given to us, which says that this P should be equal to the strength of the plate. So with the help of this information, we can write this equation where P is the strength of the weld and this is the strength of the plate. This is the strength of the plate, or the maximum load which the plate can withstand before failure, and this is the maximum load which the weld can withstand before failure. So in the question it is given to you that both these parameters or both these quantities should be equal. So this is the load which the weld can withstand without failure, and this is the load which the plate can withstand without failure. And the load is always, as you know, that the stress is equal to load divided by area. Therefore, the maximum load which the plate can withstand without failure, it will be equal to the area of the plate, or the cross-sectional area of the plate, times the tensile strength of the plate. So the tensile strength of the plate, the cross-sectional area of the plate, you can find it out from here, where the length of the plate is given to you as 120 and the thickness is given to you as 12.5. Okay, and don't confuse this T with your throat. This is not your throat. This T over here, written over here, is not your throat. Rather, it is the thickness of the plate. Okay, rather it is the thickness of the plate, or I should have written it H over here in place of T. Okay, you can write H over here in place of T. So don't confuse this T with the throat. This is not the throat. This is basically the thickness of the plate, and this W times T is giving you the cross-sectional area of the plate. So cross-sectional area of the plate multiplied by the allowable tensile stress will give you the strength of the plate, which according to the question is equal to the strength of the welded joint. Now from here you can see that W is given to you, thickness is or the thickness of the plate is given to you, and sigma T is also given to you. So you can very easily find out what is the strength of the welded joint. Next, the question asked, the question basically wants you to find out the length of the weld. So in order to find out the length of double transverse fillet weld, you have to use this equation, which says that the strength of the weld is equal to twice 0.707 times H times L times sigma T. I have already explained you in the previous slide that how you are going to get this equation. Now if you look at this equation, P or the strength of the welded joint, you can find it out from the previous equation or from this equation. Length of the this length is not same as this length. You have to find out the length of the weld. You have to find out the length of the weld, which is not same as this. This value you are only going to use in this first equation. Okay. And then the sigma t is already given to you in the question, which is the maximum tensile stress or the allowable tensile stress. So from this equation, and 2 is obviously your constant, 0.707 is your constant, h is given to you in the question as 12.5, which you can take it from the previous equation or you can take it from here. So all the values are given to you in the question, and you can easily find out the length of the weld. You can easily find out the length of the weld. And if you put all the values properly and if you are consistent with your units, you will get your answer as 37.62 mm. This will be your correct answer. Try to solve this problem at your end, and in case you have any problem, you can always contact me. And please don't confuse with this arrow. Don't confuse with this arrow. This length is not equal to 120 mm. 120 mm is the length of the plate. Again, this value is not required in this question. This value is not at all required in this question. You have, this is the length of the weld which you have to find out, which is equal to 37.62 mm. I hope these problems are clear to you. As I already told you that these problems are very important from the gate point of view, and similar questions are asked to you in the gate examination. And in case you haven't understood this problem, always feel free to contact me. You can also comment in the comment section below, or you can post your questions on your WhatsApp or on your class WhatsApp group. So that will be all for this lecture. And thank you for listening this lecture patiently. I'll see you in the next lecture.